Hello everybody. Alright, we're starting the final section in chapter 6 about really Pascal's triangle and expanding binomials, although I'm wanting to teach you kind of a minor skill that's also part of this section called combinations. So that's not truly the name of this section. Still, you need to know it, so we're going through it. What I'm wanting you to be able to do after this video is for you to be able to calculate the number of combinations of R items that you can make when selecting from a group of N items. So say I have 10 students that I can choose from, and I want to form committees of 3 students. How many different combinations of 3 students could I get from a group of 10 students? That's the type of thing that we're going to be figuring out. Now, I'm going to give you one problem where I don't give you a formula and I ask you to reason it out, and then I'll give you a formula for calculating that kind of calculation. All right? So here's the problem that we're going to kind of reason out. Suppose that you're shopping for scarves, and there are 5 colors to choose from: red, orange, yellow, green, and blue. How many combinations of 3 colors could you make, and how many 4-color combinations could you make? All right, well, when I say we're going to reason this out, let's just see how many different ways I can get groups of 3, how many different groups of 3 I can make from these 5 colors. And I'm just going to simply list out groups of 3, like I could take the red, orange, and yellow and group them together. Now let's say I just make as many groups as I can with just red and orange. I could also make red, orange, green, and I could make red, orange, blue. Now that's all the combinations I can make with red and orange. So let's make all the combinations I can make with red and yellow. We've already combined red and yellow with orange. We still need to be able to combine red and yellow with green, and red and yellow with blue. Alright, now I hope you can see the systematic way I'm going about this. Let's see how many 3 color combinations I can make that include red and green. Now I've already grouped red and green with both orange and yellow, so there's only one more group that I can make there, and that would be red, green, and blue. Alright, and then how many 3 color combinations can I make with red and blue? Well, I've already made them. I've already grouped it with orange, with yellow, and with green. So that's all the 3 color combinations I can make that include red. Now let's make the ones that do not include red. So orange, yellow, and green would be the next logical choice. And then let's leave out the green and go with blue instead. Orange, yellow, and blue will work. Alright, there's no other 3 color combinations that would exclude R and include orange and yellow. So let's make another one with orange. How about orange, green, and blue? And that's going to be it for how I can make combinations of 3 including orange, and we've already got the red out of the way. So how about 3 color combinations that don't involve orange, yellow, green, and blue? Is the only such combination. Now, hopefully you agree that I've used every possible grouping of 3 that I can, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 3 that I can make. Now, here's what I'm going to do for the 4 color combinations. I think this will be a little bit easier. Instead of listing out all the 4 color combinations I can make, I'm going to do this. If we're choosing 4 colors, that means we're leaving out 1 color, doesn't it? So say I make a group that includes red, orange, yellow, and green, that means I left out blue. If I made a group that includes orange, yellow, green, and blue, that means I left out red. So how many different groups can you make where you leave 1 item out? Well, I can leave red out once, I can leave orange out once, I can leave yellow, green, and blue out 1 time. So that means there are 5 different groups of 4 that I can make, because there's 5 different ways I can leave 1 of these 5 items out. And if that didn't make sense, then you just go ahead and list out all the 4 color combinations that you can make, and you'll find that there are 5 of those as well. Great. So this is all nice and neat when you have a small number of colors or items that you're choosing from. But let's say I had 20 colors and I wanted to know how many groups of 13 that I can make. Trying to list out all those groups is not such a simple thing to do. So it'd be nice if there's a formula to calculate the number of combinations of items you can get from a selected group to choose from. And that's what this formula is right here. If you're trying to calculate the number of combinations of n items taken r at a time, you're going to use this formula right here. Now, when I say the number of combinations of n items taken r at a time, what I just did was I had 5 items and I chose groups of 3. Or I had 5 items and I had groups of 4. That's what we did in the previous example. Now there's a couple of different notations that you can use to say that you have n items that you're choosing from and that you're choosing this many of them. All right, NCR. For instance, I would have written in the last example that I found out that 5C3 is equal to 10. Okay, now how do you read this? Well, a couple different ways. You could say 5 items chosen 3 at a time is equal to 10, or the number of combinations of 5 items that you can make 3 at a time is equal to 10. All right, and then similarly we could have said that 5C4 was equal to 5. All right, and the formula, and I'll show you how to actually use it in the next couple examples, is this. You do the number of items that you're choosing from, factorial, so it would have been 5 factorial, over the number of items that you are taking, how many you're taking at a time, factorial, times the difference in the number that you have and the number that you're choosing to use, factorial. And instead of writing NCR like this, you can write it in parentheses where you say, here's the number of items I have to select from, and here's the number of items that I'm taking at a time. Okay, so let me go ahead and show you the mathematical, the way you use it in this formula to calculate the 5C3 that we found a moment ago. All right, 5C3 equals, now, n factorial, and the n would be the 5, so that's 5 factorial, and what, well, I'll put that in a moment. I was about to elaborate on this a little bit. Over r factorial, and r is 3, times n minus r factorial. Well, n minus r here would be 5 minus 3, or 2 factorial. Now you may or may not know or remember what a factorial is. A factorial is just when you take an integer, a positive integer, and you multiply it by every positive integer that is less than it. And so that would mean for 5 factorial that you're multiplying 5 times 4 times 3 times 2 times 1. All right? Then 3 factorial would be 3 times 2 times 1. And 2 factorial would be 2 times 1. Very simple to use. I don't actually have to do this entire multiplication up here or down there, though, because I hope you can see there's some cancellations that can be done. In the numerator, do you see how I've got a 3 times 2 times 1 and in the denominator? So I can cancel this and this out. And that leaves me with 5 times 4 over 2 times 1. That's 20 over 2, which is equal to 10. Right? Which is the same thing we got just by reasoning it out. Great. So that's how you calculate the number of items in that you can take, r items at a time. Try a couple of examples here. Use the formula, see what you come up with for 7C3, then pause the video, do that, and then unpause to see if you got it right. All right, here's me plugging in the numbers into the formula. There's my n is 7, so I have 7 factorial. My r is 3, so I have 3 factorial. And then n minus r, 7 minus 3 is 4, so I get 4 factorial. Notice that 3 and 4 added to 7. That'll happen every time that these two factorials down here, the numbers that you're starting with, will add up to the whatever you're taking the factorial of up there. All right, and then here's me expanding those factorials. And then in terms of cancellations, I would like to always cancel out the larger factorial with its corresponding parts up above. In this case, I have a 4 times 3 times 2 times 1. In the denominator, they can cancel out with this 4 times 3 times 2 times 1, so that would be the greatest common factor for the numerator and denominator. And if you're really smart, you can, well, not really smart, but observant, you can also notice maybe that you got a 3 times 2 here, which is 6, that I could cancel out with that 6. And so I'm left with 35 over 1, or just 35. All right, one more for you to choose, and I just wrote it a different way, but this is like 6C4. Calculate that, then check your answer. All right, there's everything plugged into the formula. And there's those factorials expanded. And you'll notice you can cancel out this 4 factorial with a 4 factorial up there. You're left with 6 times 5 over 2. And 30 over 2, of course, is 15. All right, so there are 15 ways that you could have 6 items and make groups of 4 out of those 6 items is what that means. Thanks for watching, guys. The next one will be about expanding binomials, and this combination stuff will be involved there. See ya.